Good morning, students. Today we will study about limiting reactant, then molarity, mass percentage, volume percentage, parts per million, mole fraction, etc. And we will also do some numericals. First, limiting reactant. What is limiting reactant? Actually, limiting reactant is that reactant which is present in small amount or on which the production or the formation of product depends. That is why that is known as limiting reactant or limiting reagent. That is, limiting reactant is present in lesser amount. We will do one numerical here. So question is 1 gram of magnesium is burned in a closed vessel. So numerical is 1 gram of magnesium is burnt in a closed vessel which contains 0.5 gram of oxygen, which is the limiting reactant. You have to find out which one is limiting reactant. What is the amount of magnesium oxide, that is product, formed in the reaction. So first we will write chemical reaction. Magnesium when burns, that is oxygen is required and it will give magnesium oxide. Balance this equation. Here it will be 2, it will be 2. So first, what is the atomic mass of magnesium? That is 24. So here 2 magnesium atoms are here. So 2 multiplied with 24, 48 gram. Here 16 multiplied by 2, that is 32 gram. And here 2 into, in bracket, 24 plus 16, it will give 80 gram. So when 48 gram of magnesium reacts with 32 gram of oxygen, then 80 gram of magnesium oxide is formed. It means 48 gram of magnesium reacts with 32 gram of oxygen. So 1 gram magnesium reacts with 32 divided by 48 gram, which will come 0.67 gram. It means 1 gram magnesium reacts with 0.67 gram of oxygen. But in question only 0.5 gram of oxygen is given. That is 0.5 gram oxygen is given. So oxygen is present in less amount. So oxygen is limiting reagent. So when 32 gram of oxygen reacts with magnesium, that is 48 gram of magnesium, then 80 gram of magnesium oxide is formed. So what amount of magnesium oxide will form when 0.5 gram of oxygen will react with magnesium? Then 80, it will be 80 divided by 32. When 32 gram reacts with magnesium, 80 gram of magnesium oxide is formed. When 0.5 gram of oxygen reacts with magnesium, then 80 divided by 32 multiply 0.5, and you will tell me what amount will come here. Now we will know about few terms, that is strength, then mass percentage, then volume percentage, then molality, fifth one molarity, then normality, and then mole fraction. First, strength. How you will know the strength of given solution? Strength is amount of solute in grams present per liter of the solution. That is amount of the solute in grams per liter of the solution. That is volume is given, volume of solution. That per liter means the unit will be in liter, or that may be decimeter cube. That may be decimeter cube. Now mass percentage. Mass percentage is the number of parts by mass of one component, and that component in solution is, one component is known as solute, which is present in less amount, and other component is known as solvent, which is present in large amount. So mass percentage is the number of parts by mass of one component per 100 parts by mass of the solution. Now next one is molality. Molality is represented by small m. It is the number of gram moles of solute dissolved per kg of the solvent. That is, gram molality is equals to gram moles of the solute dissolved per kg of the solvent. That is mass of the solvent in kg. You can write in this way. And molarity. Molarity is represented by capital M, and it is defined as the number of gram moles of solute dissolved per liter of the solution. That is gram moles of the solute divided by volume of solution in liters. Now from here you can see, here it depends upon mass, and here molality. That is molality depends upon mass and molarity depends upon volume. So which one is best, molality or molarity? Molality is best. Why? Because molality depends upon temperature, because volume changes with change in temperature. There is one equation of molarity, that is M1 V1 plus M2 V2 is equals to M V1 plus V2. That is M1 V1 plus M2, you can also write in this way, is equals to M3 V3, where V3 is equals to V1 plus V2. Next is normality. Normality is defined as the number of gram equivalents of solute dissolved per liter of the solution, that is gram equivalents of the solute dissolved per liter of the solution, that is volume of solution in liters. Now we studied about a term, that is gram moles of the solute, and in normality gram equivalents of solute. How you will calculate moles when mass is given, that is given mass divided by molar mass, given mass divided by molar mass, and equivalent, that is gram equivalent of the solute is equals to mass of solute in grams divided by equivalent mass. Now how you will calculate equivalent mass? In case of acid, equivalent mass of acid is equals to molar mass of acid divided by basicity, that is number of replaceable H positive ions which are present in acid, that is number of replaceable ions. In case of base, that is equivalent mass of base, same molar mass of base divided by acidity, that is number of replaceable OH negative ions. In case of salt, same molar mass of salt divided by total positive charge on cations, on cation. And in case of element, that will be equals to atomic mass of element divided by valency of the element, atomic mass of the element divided by valency of the element. And in case of ions, in case of ions it will be formula mass of ions, because in case of salts we take formula mass of ions. In case of ionic, in the ionic crystals, we take formula mass of ions divided by charge on ion. Now one more term is there, mole fraction. Mole fraction is defined as the ratio of number of moles of one component to the total number of moles present in the component, that is total number of moles present in solution. That is, if you want to, it is represented by X. If you are if you want to find mole fraction of, suppose, A component, then you will represent mole fraction of A in this way, that is mole fraction of A, that is XA, is equals to NA divided by Na plus Nb. That is number of moles of one component divided by total number of moles present in solution. Similarly for B, it will be Nb divided by Na plus Nb. The most important thing is Xa plus Xb will always be equals to 1. If there are n components, then Xa plus Xb plus so on, that sum total will always be equals to 1. Now we will do one numerical. Calculate the mass of cane sugar and water required to prepare 250 gram of 25% solution of cane sugar. Okay, calculate the mass of cane sugar and water required to prepare 250 gram of 25% solution of cane sugar. How you will solve this numerical? Here mass percentage is given, that mass percentage is given, that is 25%. Again mass of solution is also given, that how much we will make solution, that is mass of solution is given, that is 250 gram. So how we will find out the mass of cane sugar? If percentage is given, that is mass percent is equals to, how we calculate mass percent, that is mass of one component divided by mass of solution multiply by 100. So mass percent is equals to mass of solute, and in this case solute is cane sugar divided by mass of solution multiply by 100. This is given, this is 25 is equals to mass of solute, we don't know, let it is X, divide by mass of solution, that is given 250 gram multiply by 100. So X will equals to 250 multiply by 25 divided by 100. So it will come 62.5 gram. This is mass of solute. This is mass of solute. So it means that mass of solute, if you are representing solute by A and solvent by B, then mass percentage or the percent of A will equals to A, that is mass of one component, divided by mass of solute plus solvent multiply by 100. Similarly mass of B, here it will be B divided by A B, that is mass of solvent divided by mass of solute plus mass of solvent multiply by 100. Similar definition will be of volume, that is the number of parts Y by volume of one component per 100 parts by volume of the solution. Same here, in place of mass, here it will be volume. So you will write all these definition. Now molality. First, to find out the mass of solvent, what you will do? Solution, mass of solution, that is mass of solution minus mass of solute, that is 250 minus 62.5. 9, 2, 7, 14681, that is 187.5 gram water and 62.5 gram, that is cane sugar you will dissolve to have 250 gram solution of 25% solution of cane sugar.